Hey everybody, welcome to Space Time with Dave. I am Dave, and this is my PixInsight workflow tutorial. I'm going to show you how I process my DSLR Deep Space Astrophotography images and to get something like this. So this is my Trifid Nebula shot from earlier this summer, and this was shot with my Canon 7D Mark II, and I think it's about an hour and a half of total integration time. So that's the final product that we hope to achieve, and let's open up my stacked file. So this is my stacked version. I stacked this in Deep Sky Stacker primarily because it's just easier and quicker, but for best results you want to probably stack in PixInsight, but this works for me. So first thing I need to do is I always grab my dynamic crop tool and crop out these stacking artifacts at the edge of the image. I kind of zoom in here, and if you hold spacebar you can pan around. And so I'm just gonna crop out, kind of to the edges, and maybe you want to crop the image in a little bit further later, but for now let's process the whole, as much of the image as you can. And so that looks pretty good, and hit the check, then close that. Okay, so first step is background neutralization and color calibration. So grab your preview tool here, and we need to find an area of background, and it's a little bit difficult when you have such a dense star field, so you got to find like a little dark spot. And so for this image I've found that like this area over here seems to work pretty well. So it's okay to have kind of some smudges in there, but you definitely want to keep out these bright stars. You're looking for a bunch of pixels that is representative of what the background should look like, or what the background, you got to tell PixInsight what your background is. So I think that'll work. It doesn't need to be very big, and that should be plenty big enough. So processes, color calibration, background neutralization, and hit your reset button to make sure you're starting with the latest settings, or with default settings rather. And default settings work fine usually for background neutralization. So select your preview, drag and drop. Okay, it looks ugly, but that's just because of the auto stretch gets screwed up. So we just re-stretch it, and now it starts to look pretty good. Background looks good. Looks grayscale, grayish, which is what it should look like. Color is not quite correct, so we do color calibration next. Process, color calibration. So for this tool, you can use a white reference. I generally find I don't need to. Just leave the default settings all here and just add your same background reference and apply it. And pretty much all of my DSLR images are coming out just fine without using a white reference. And so if I auto stretch it, so what I'm looking for in color calibration is mainly I look at the star colors. I ignore the nebulosity and look at the star colors. We know that stars should be varying shades of blue and yellow orange. So yellow orange, blue. So if the star colors are right, then that tells me that the rest of the colors in the image are right or close enough. So that looks good. I don't need the preview anymore. Okay, so the next step here is noise reduction. I see people a lot of times doing noise reduction on the nonlinear image after they've done histogram stretching, and the reason you don't want to do that is because if I did histogram stretching of the image now, I would be stretching the noise. So let's get rid of the noise before we do that. So this image is already pretty low in noise. The Canon 7D Mark II does a really terrific job, but we can clean this up. So And what we want to do in removing the noise is we just want to remove it from the low signal to noise areas, the dark background. We don't want to apply noise reduction to the bright areas, the nebulosity or the stars, because those already have a very good signal, so they should be generally low noise. So to do this, what we do is pull a luminance mask, and I need to stretch the luminance mask. There's the auto stretch. So what I need to do is I need to do an auto stretch, a nonlinear luminance mask on my linear image. So processes, we need the screen transfer function, and we need the all processes, the histogram transformation tool. So what I'm going to do is cancel the auto stretch just to make sure that I'm starting with make sure I'm getting the right data, and hit the button, the auto stretch button in the screen transfer function tool. Then use the triangle to send that information to the histogram transformation tool. Come back over to this, to my luminance mask, kill the auto stretch, and then apply the histogram transformation. So it doesn't look like anything's changed, but what we did is we just permanently stretched the mask, which is what we need. So I don't need that for now. And now to apply the mask, I can just drag it like this, and then minimize, because I don't need that. Okay, so now remember, with masking, everything that's red is protected, and everything that's not red, or in this case white, is not protected, which is the opposite of what we want. We want to invert this mask because we want to protect the high signal to noise ratio regions. So I can do that with mask, invert mask, and also note the keyboard shortcut Control-Shift-I is pretty handy dandy just to cycle between them. Okay, so that's cool. So next I'm going to make a preview of mostly background, but I like to include some nebulosity in here to make sure that I'm not doing bad things to my nebulosity. So here's my preview, and this is what I'm going to work on for getting my noise reduction settings right. And Control K shows and hides the mask. So Control K toggles that on and off. So I know I still have a mask on, and you know you have a mask on because that's what this this turns yellow. Show you you're using a mask. Okay, so for noise reduction, I like to use the multi-scale linear transform tool, and this is one of these tools that's kind of intimidating at PixInsight because look at all these layers. It's not like one slider to increase noise reduction. But that's a really good thing, because what this does is separates your noise reduction into wavelet layers. And what wavelet layers do is allow you to target details of specific pixel scales. So for example, here layer 1 is pixel scale 1. So any of the settings I do on layer 1 is going to affect details on the smallest of pixel scales, which is where most of the noise lives. You can see the noise in here. You can see it as individual pixels, individual blocks. And then layer 2 and 3 and 4 and so on are larger details. So like the stars might be layer 4, or the residual layer, a higher layer. So we don't want to noise reduce those. Since most of the noise resides on layer 1, I'm going to turn on noise reduction for layer 1, and this image is pretty clean. And generally, I like to err on the side of less is more. So I'm going to reduce the threshold to 2. And under amount, I'm going to do 0.33 and 3 iterations. So according to the PixInsight documentation, doing less amount and more iterations is generally gives you is preferred over. So this would be the same if I did 1 and 1 iteration, but instead I'm going to do 0.33. So I'm going to separate it into 3 iterations, and I think this works pretty well. Then layer 2, I'm going to do quite a bit less. I'll do just 1 and amount 0.5 with 2 iterations. And layer 3, I'm not even sure I want to do any on layer 3. Yeah, maybe just a little tad. So we'll do like 0.5 and just 0.5 with 1 iteration on layer 3. So I think this will be pretty good settings for this image. The last thing is the target. Change this to just luminance. We're going to come back and we're going to we're going to do this separately in 2 steps. We're going to do luminance and then chrominance. But first we'll do luminance. So apply this to my preview. And this takes a second to figure itself out. And okay, so that's done its thing. And when you're in preview mode, you can undo and redo with this tiny little button here, reset, or actually it's this one, sorry, undo preview. Or you can also do Control Shift Z to toggle back and forth. So Control Shift Z, that's before, that's after, before, after, and pretty smooth. You look before and after. Before and after. So what you're looking for in here to know if you've done too much noise reduction, groupings of stars like this. If you do too much noise reduction on higher layers, you will start to notice artifacts. You'll start to notice like a grouping. And maybe a little bit you can see it here, but it's really not very noticeable. So yeah, I think this is pretty good. What I'm going to do, just for a demonstration, I'm going to undo this. So this is my default state. And I'm going to come over here and apply way too much to layer 3. I'm going to move layer 3 up to like 3 and 2 iterations. And so let's see if this generates the artifacts I was referring to. And if not, I might just cut this part out. Okay, yeah, so this did create the kind of the ugliness that I was referring to. So if you zoom out, it looks kind of muddy, and when you toggle it on and off, you can sort of see, this maybe not be the most clear example, but you can sort of start to see grouping. So let's see, let's turn it, that's off, that's on, before, after. So you'll notice like these things start to group. And yeah, so it looks like almost like tunnels between, maybe like, sort of looks like tunnels, like if you look at like an ant farm, you know, how they tunnel down through the soil. So that's what you're trying to avoid, and I think that's a pretty common mistake. I see that a lot when people do too much noise reduction or too much noise reduction at these upper layers. So I'm going to move that back down to the settings I had because I think those were pretty good, and I'm just going to go ahead and apply those to my main image. Okay, so now I've done my luminance noise reduction on my main image, and I can use the History Explorer to toggle it before and after. So it's pretty subtle. This image is already pretty low noise, but it's important to remove the noise so that when we stretch it, and then when we enhance the saturation and do things like sharpening, that the noise is already gone. Okay, so that's good. And the next step is, we're not done with noise reduction. There's another step. We're going to reduce the chrominance noise, and so I'm going to reset, and I can use the same preview. If you look closely, and again, the Canon 7D Mark II does a great job, so it's a little less obvious, but there's sort of, in these noise areas, there's sort of like some green and some blue and some red. So that's chrominance noise, and we can remove that using the multi-scale linear transform. So to do that, reset, and I'm going to change to 7 layers, Why 7 layers instead of 4? This is just kind of borrowing from another tutorial that I found, and it seems to work pretty well. So I'm just going to use default settings on layers 1 and 2, and 3 and 4 I'm gonna reduce it to 2 and 1. And these generally seem to be good values for doing the chrominance noise reduction. Under target, make sure you select chrominance and apply it. Now this is going to take a bit longer because it's got to go through 7 layers, so just be patient and grab yourself a drink, some beer. I try to drink 2 or 3 beers for every image that I process. Okay, chrominance noise reduction done, and kind of doesn't look like much has changed, but when you zoom in here and Control-Shift-Z, so notice that my background now looks, see, there's a little bit of color and there's no color. A little bit of color, no color. Color, no color. So it's pretty faint. Hopefully it shows up under the, the YouTube compression. So this is really important, because if I don't do this, then when I stretch the image and when I go to saturate it, I'll be saturating this noise, and then I'll have a really weird multicolored background. So removing the chrominance noise goes a long ways towards making your images look nice and clean. So that's good, and now we'll go over here and apply it to my main image. So now I'm done with noise reduction. So I'm going to minimize that, toss that guy over here, and kill the preview because I don't need it, and remove the mask. Okay, so now at this point I'm ready to do my nonlinear image stretching. So I'm going to kill the preview and restretch, and go back to my histogram transformation. Do that, reset that, select my view, and I'm going to drag my screen transfer function over to histogram transformation. And now I'm going to open up the real-time preview, and the real-time preview is totally blown out because I'm using basically I'm double stretched, so I just need to cancel the auto stretch. Okay, so how much you stretch the image, don't think there's necessarily a wrong answer on here, but with nebulae like this, I like to just let the auto stretch do my midpoint stretching for me, and at least I know this way all of the detail in the scene is revealed in the image, so kind of takes the guesswork out of it. But now I do need to darken the background, so I'm just going to work on the left slider here and kind of zoom in. So as I drag this over, my background gets darker and I get a nice contrast. But I also start to clip pixels, and so you want to watch the shadows value here to see how many pixels you're clipping. Right now I'm clipping 71 pixels, so it's not really that big deal. And look at the percentage, very low. So generally I bring this up to, if you go here, you're gonna start clipping all these pixels, and now look, I'm clipping 0.01%, so really not even that much. But I don't want to lose anything because there's very faint detail in this blue nebulosity out here, and there's even this dark nebula, and this is something that I don't see in a lot of Trifid pictures, is this dark nebula here. So generally what I do is kind of go right to where this graph starts to pick up, somewhere right in here, and look at the percentage of pixels clipped. So I can clip something like that's probably pretty good. I'm only clipping 500 pixels and 0.0028%, pretty good. And so that's, yeah, I like that. And I can always come back and add contrast and make the background darker later. So I like that. So I'll apply those settings, and there we go. So that looks good. Now my image is stretched and ready to move on to the next step. And so there's a couple of different ways to go about this, whatever your next order here of operations. I'm going to work on the detail in the nebulae a little bit. And so the first thing to do is I like to do a little bit of local histogram equalization. So this is a neat tool that helps bring out detail inside, helps with contrast on the inside of these nebulae. But I don't want to apply it to the whole image. I want to use a mask. I tend to use a lot of luminance masks in my processing. So I generated a luminance mask and I just apply it and bring this down here, minimize that. Control K to toggle the mask on, and in this case I do want to protect the dark areas. I just want to apply local histogram equalization in here. So if you want to play around with this, you can create a preview, and you can use the real-time preview here and see, change the amount slider to see. This is kind of just personal preference. It depends on what you're trying to do, what it is you're trying to bring out. I generally end up somewhere around 0.6, maybe 0.65. That's before and after. So that's okay. I think I'm just going to apply that. Okay, so that's applied, and so I generally, I believe in less is more in these processing, and too much processing or over processing can kind of make images look unrealistic. So subtle changes are what we're after. So let's take a look at the before after changes here. So you see it kind of just enhances these dark nebulae and makes them stand out a little bit, and that's good. So I'm going to remove the mask, and at this point I need a star mask. So I'm going to work on some image sharpening, maybe just a tad, and I'm going to need a star mask for that. So process, mask, generation, star mask. Star masks are tricky. One of the things is that they take a long time to generate, and you really just have to do trial and error to find out what works best for you. In this case, if you have a noisy image, you're going to want to increase the noise threshold. In this case, I don't have a very noisy image, but I have a ton of really small star details. Maybe this is kind of some noise down here, so I'm going to increase the noise threshold to 0.2. And at my pixel scale with this imaging system, scale of 5, or excuse me, a scale of 6 seems to work better to pick out larger stars. Structure growth, I go 0, 0, and compensation, I'll probably do 1 on this one because that'll help pull out smaller stars. Smoothness, value of 12 seems to work well for my images, and I turn on binarize here and bring the midtones up. So these values that I've come up here are mostly just come from an embarrassing number of hours of trial and error to see what works best. It's going to depend on your pixel scale, which depends on your focal length and many, your sensor, what type of sensor, how long the exposure is, lots of things. So these work well for me, and but you may need to do trial and error on each one of these values independently to see if they work for you. Okay, so hopefully this is good. So the way I check is I like to zoom in, and I'll go 1, 2, 3. And then over here, if I go 1, 2, 3, now I know they're the same scale, and then I can just kind of hold the mask over here. And if I hold it, it kind of goes transparent. So I can see, where there's stars to see if I'm masking them appropriately. So an appropriate star mask, you don't want these to expand too much, so you're masking a big area around the star. You really want to mask just the star itself. And then see, am I picking up enough small stars? Am I picking up enough of the large stars? And are my my stars actually round in the mask? If the smoothness value is too low, they can be not round. So there's a number of things to look at for here. Here's a large star that it picked out, but here's a very large star that it did not pick out, which I think I'm okay with because this star has all kinds of diffraction going on. So I'm just gonna kind of ignore it. So I think this works well, and I could spend a lot of time refining the mask, and but I think that's gonna work. Okay, so I've got my star mask, and so now I need a new luminance mask. And pretty much anytime you make a change to the image, just generate a new luminance mask. And I'm going to do a little bit of deconvolution on here. And Control K to show the mask. So yeah, I want to protect the dark areas. I just want to apply deconvolution to the bright areas. So again, I'm going to use my same preview, Control K, toggle and untoggle mask. Processes, all processes, deconvolution. In order to do deconvolution properly, you need a point spread function. And I'm not going to go through that. So that's something that I've not really been able to do a very good job with yet. It's going to require a lot more trial and error to figure out. So for now, or if anybody has some tips on how to generate these point spread functions, let me know. I have been through some tutorials and haven't quite figured it out. So I'm just going to leave default values here, and I generally like to try 15 iterations and turn on de-ringing, local de-ringing, and my star mask that I previously generated, and then apply. Okay, so this is gonna make a pretty small change before after, and it does do a pretty nice job of just kind of bringing out this subtle wispy details in this dark nebula in front here. You got to be careful. Point spread or the deconvolution can do really ugly things to stars, and you know aside from ringing, but you can kind of get these internal donuts, and so I don't know if you're going to be able to see that in the YouTube compression or not, but it's brighter around the outside and darker on the inside. If I do before, that's before after. So it's kind of an ugly artifact, but we're going to fix that in the next step when we shrink the stars. So that's okay for now. So it's a little bit of sharpening, a little bit of enhancement. Image sharpening has been one of the biggest challenges, something that I really haven't had a whole lot of success with in these images yet. So I'm just going to go with this. So just a little bit of deconvolution to just make it look a little bit nicer. So this takes a little while. The more iterations you do, the longer. So, go grab yourself another beer. Okay, deconvolution is done, and so that's pretty much all I'm going to do for sharpening on this image. And I like what it's done. You don't want to do too many iterations of deconvolution. You'll start to get these weird, like white snaky artifacts or something. So done with that, and done with my mask, so I'll take that away. And so the next step is to work on the stars. Usually we shrink these stars in our DSLR images since they tend to be bloated. So for this, I'm going to find there's my star mask, and I'll just reapply it and minimize that. Okay, so Control K, toggle it on just to make sure that I'm masking the right thing, which I am. And for this, Control K, yeah, off on. Okay, for this we use the Morphological Transformation tool. This is another tool I've spent a lot of time experimenting with my images to see what's going to work best. Improper morphologically transforming your stars can result in making them kind of have like a dim ring and then a bright ring in the center, which was very unnatural, or just dimming the whole star entirely, which is also unnatural. So the best operator to use, I've found, is morphological selection. 2 iterations, usually the amount left at 1. And the selection, so the way this works, anything that's below 0.5 will reduce the star size, and any selection above 0.5 will increase it. At a value of 0.5, absolutely nothing will happen. So we want to reduce the star size. And so I think generally like somewhere around 0.44, 0.45, yeah, let's do a little bit less, maybe 0.42. It's going to give me the best results. Your structuring element, I think this tends to depend on how many pixels make up your star, and so you can see I'm way oversampled on these DSLR images, so I have lots of pixels to play with. So I leave this at 9, and the diamond setting here, so that seems to work well. So let's just try that and see what it looks like. Okay, so a pretty subtle change. That's before, that's after. And I like to kind of look at the whole big picture here, before and after. So they all are dimmed a bit. Our nebula looks nice, before, after. And so let's zoom in and kind of look at the stars here. And this is kind of giving me a like a blocky shape, but what I'm looking for is on the edges here. I can kill this preview, I don't need it. So let's go before, after, and look closely at the stars, at what it's doing. So I kind of don't like that. The amounts of dimming is pretty nice, but it's kind of making them look blocky in the center. So let's try the circular structuring element. Okay, so now notice when I change it to the circular structuring element, so now it doesn't look blocky in the center, but it just dimmed the whole thing. So it kind of just made them all a lot more dim. Kind of look at my big picture. Kind of looks nice on the big picture, but you know, I zoom in here. Is that really what I want it to do? That star looks a lot smaller. So let's try a circular element, but with a little bit less selection, or a little bit more, I suppose. Okay, so before, whoops, let's see, that's before, that's after, before, after. So it makes this star look a lot better. Here it looks blown out. This looks like a pretty solid white disk, and here now we get kind of like a nice more even roll off. So I like what that did there. And kind of pan around and look at your stars and see what it's done. Here, blown out, totally kind of a white disk, and now much more mellow, more round, even look to the star. Let's go before, after on here. So this looks pretty good. I could play around with this a little bit more. You know, what you generally want to see in your stars is a you know, that they should be brightest in the center and then have a smooth roll off. And so some of them are a little bit better than others. You know, this one looks kind of digital, kind of processed. It's not quite the smooth transition that you would look for. But this one looks nice, and these ones look pretty nice. So I'm pretty satisfied with that. Again, you could spend more time. You know, you can spend a lot of time with every single step of this processing, and I encourage you to do so to see what works best for you. But for now, I'm going to go with that. And let's look at the whole picture again. This is the before, and this is after. Before, after, to see just how it's dimmed the whole star field a bit, which is what we're looking for. So that's good. Close that and remove the mask. So now at this point, I'm pretty much ready to go ahead increase the saturation and work on the contrast. I'm pretty satisfied with the sharpening and with the noise reduction. So let's go ahead and do that. I don't need the preview. And okay, so I want to saturate the image, but I don't want to oversaturate. I don't want to saturate the background. Actually, let's work on the overall contrast of the image. And so I can bring up my histogram transformation tool again, and I'm gonna zoom out. And so it looks like I can bring the darks up, make these a lot darker without clipping too much. I can go to about here. And so take a look. Let's open the real-time preview and take a look at how much darker my background is getting. This area in particular here I want to be careful of, because the blue extends out around this dark nebula here, and I don't want to clip that detail. If I go here, I'm starting to clip way too much. So I'll go into maybe about there. Only about 0.02% of pixels clipped, so I'm okay with that. All right. Okay, so now let's do saturation. So I'm going to generate another Luminance Mask. Okay, so I'm going to apply this and minimize. And I'm going to do Control K to make sure my background is masked, because I don't want to saturate the background. I want to saturate just the bright areas. Process all processes, curves transformation. Okay, so here, turn on a real-time preview, and I'll go to my saturation tool. And so I usually need to pull this way up. That's a bit too much. Somewhere in here. To get these beautiful colors out of the nebula, but it also saturated all these background stars, kind of a bit more than I want. I like saturated star looks. Some images, have less saturation in stars, some more. Kind of depends on personal preference and what you're going for. That's a bit much, so I'm gonna do just kind of a bit, and I'm not really looking at the nebula. I'm just looking at the star field. As to how saturated, right? So that's too much. Maybe somewhere in here, something like that, I think is what I like to what I want to see in there. So I'm going to apply that. Okay, so now I'm going to remove the mask. So now I want to saturate, kind of just my nebulosity here, and maybe some of these brighter stars. So what I can do is, let's find my two masks here, and I'm gonna combine. What I'm gonna do is subtract the stars from my Luminance Mask using Pixel Math. And okay, so all you do here is you just grab the name, and I can just double click on it and copy rather than trying to type the whole name out. So I'm going to do that Luminance Mask minus my star mask, STR minus star mask. And destination, we want to create a new image. Boom. So cool. All right. So now I will be saturating just everything that's white on here, and so all those stars are going to get not saturated. So this is kind of something new that I've been doing, is then working on the mask itself. So I'm going to just darken maybe just a little bit, because I don't really want to saturate that field so much. Yeah. Maybe like that. Okay. Oops. Close that, and I'll do that. All right. And apply the mask. So there we go. So Control K, and now do my curves transformation and reset it, and now do some more saturation. So now, I mean, if I go up here, this is way too much, but I'm just kind of just saturating the bright areas, which is what I'm looking for, and to leave the stars kind of where they are. And so let's bring that up. Yeah, something like that. I think looks pretty good. And I'll apply that. And so there we go. That is pretty much it. Oh, one last little tool. I'm gonna remove my mask. Processes, all processes, SCNR, and so this just to remove sort of any lingering green. If you zoom in on the star field here, kind of some green going on that shouldn't be there. And it's mostly just leftover green noise, I believe. So SCNR and apply that. Leave it at green. It just takes a second. And so if I do before, after, pretty subtle. It's not really bad in this image. Some images will have a lot of lingering green. If I zoom in here and then, so that's before and that's after. Pretty subtle, but nice to do nonetheless. Some images will definitely need that more than others. So yeah, that's pretty good. I'm pretty satisfied with that. I might tweak the the curves a little bit more. I could add some more contrast by crushing the blacks a little bit, and maybe something like that. But probably not. Generally, I like to not crush things, and so yeah, I'm pretty satisfied with that. I think that's a pretty good process. Maybe a bit much saturation in some of these stars now that I'm looking at it. So going back and adjusting the star mask and the amount of saturation that you put into it would be the thing something to look at improving on. Let's take a look at my previous processed version here and kind of compare the two. So on the left here is the one that I just did, and this is from several months ago. It looks like I got pretty much the same result there in the two. So the amount of saturation and the amount of contrast in the image is kind of depending on personal preference and what you're going for. Yeah, so that's pretty much what I do. That is so that's it. Hopefully you found this tutorial useful. Hopefully I was clear enough, and the main things are the multi-scale linear transform for denoising the image prior to stretching so you want to do your noise reduction on the linear image, and that's because when you stretch the image, you're going to be stretching the noise. So let's remove the noise before we stretch it. That's the strategy, and I think it makes a lot of sense, and I think it works really well. So hopefully you found this useful, and I didn't ramble on too much. And if you have any questions or comments, or if you have a better way of doing something than I have, I would really like to hear about it. Leave me a comment down below. I will post other links to other tutorials as I get them online. And so thanks a lot, and we'll catch you next time.